This is the fourth video, the second video for Unit 5. So we're going to start off with number 7. This will hopefully be the last video. Number 7, a movie theater charges $5 for an adult ticket, $2 for a child ticket. One Saturday, the theater sold 785 tickets for $3,280. How many children's tickets were sold? Now, in order to do this problem, you need to do two separate equations. It looks like you can complete this in one equation, but you cannot. You need to do two separate equations. So, if we take adult tickets and designate them as our X, and we take child tickets and designate them as our Y, we know two things. We know one thing is that when we add the number of adult tickets plus the number of children tickets, we're going to get 785. So one of our equations is going to be X, the number of adult tickets, plus the number of child tickets is going to equal 785. We also know that when we multiply the amounts charged into the equation, we made $3,280. So we know that $5 per adult ticket, so $5 per adult ticket, our X, plus $2 for each child's ticket equals $3,280. So this one we're just talking about the number of tickets sold. This one we're actually talking about dollar amounts. So it asks us how many tickets the children sold. In order to do that, we can do that in a couple of different ways. If we do it by elimination, then what we need to do is get the same coefficient, different sign, positive and negative. So in order to get the same coefficient, we can multiply this top equation by either 5 to get -5 to get rid of our X, or -2 to get rid of our Y. So let's go ahead and multiply it by 2. -2 times X is going to be -2x. I'm just going to do this in one step. -2x minus -2. So I'm multiplying this equation by 2. -2. When I multiply that by the y, I'm going to get 2y equals 785 times -2 is -1,570. I think we did this in class already for some of you. 5x minus 2x is 3x. This cancels each other out, which is exactly what we want. That equals 3,280 minus 1,570 gives us 1,710. Then when we divide by 3, goodness gracious, we get X equals 570. X, we know, represents our adult tickets. So we sold 570 adult tickets. But it's asking us for how many children's tickets were sold. So we need to plug this X back into our equation. The easiest equation to plug it back into would be the X plus Y. So if I have x plus y equals 785, I can take my 570, plug that in, plus y equals 785. Then I'm going to subtract 570 from both sides. And I get y equals, and the answer is 215. So that's how many children's tickets were sold. So the big thing is figuring out how to do your equations. You do two equations. One is just where you know that the number of adult tickets plus the number of children tickets is equal to 785. The second is the cost per adult ticket plus the cost per child's ticket is the total amount of 3,280. All right, moving on. An office manager must decide between two options to fill the copy needs of her department. She wants to find the more economical option, meaning the cheaper one. Option 1, Action Copy offers to lease a copy machine for a fixed weekly fee of $10 and an additional charge of 7 cents per copy. Okay, so right there, I know that Action Copy is going to cost a fixed amount of 10, which we know as our y-intercept, and an additional charge of 7 cents per copy, which would be our rate of change or our slope, or so we would include that as 0.07 x. This is the rate of change because we know if we have 10 copies, it's going to cost us 70 cents. If we have 20 copies, it would cost us $1.40. I'm sorry, if we had 10 copies, it would cost us, 70 cents. If we had 20 copies, it would cost us $1.40, and so on. So every single copy that we make is being multiplied by the 0.07 cents. Plus, you're paying a fixed fee of $10. That doesn't change. Just the amount that we are when we copy changes. So for the same machine and comparable service, FastPrint offers a fixed charge of $25 and 2 cents per copy. So our equation would be our fixed price of $25, and then the rate of change is 2 cents per copy. So what's changing is however many copies we have, we multiply that by 2 cents. This doesn't change. This is our constant. Okay, is there a certain number of copies where the two companies charge the same amount? And if so, how many copies are made and what is the charge? Okay, so we're going to look at, we know that X is the number of copies and Y is the amount that charged. So in order to figure this out, we're going to look at, we can do elimination. We can take our two equations, Y equals 0.07x plus 10, and y equals 0.02x plus 25. And we need to find the same number, same coefficient, different variable. Oh my goodness, same coefficient, different sign. So we're going to, we can multiply everything by -1 because we have the same coefficient in front of our y, and eliminate our y. So in order, when we do that, we get y equals 0.07x plus 10, and -y equals 0.02x plus 25. Now, for those of you who are paying attention, you may say, but Ms. Lavelle, this isn't in standard form, this is in y-intercept form. And that is okay. We still have all of the same values lined up on top of each other, so we can use the same equation and the same process as we've done. We're going to, when we add these together, we get 0, which is exactly what we want. It's okay. Then we've got, this becomes a negative, this becomes a negative. 0.07 minus 0.02 is 0.05x. 10 minus 25 is negative 15. Then I'm going to add 15 to both sides because I want to get that x by itself. And look at all of a sudden now there's our 15. So we have 15 equals 0.05x. Then we can divide. Do you see? I'm still doing the same thing over and over and over again. You just have to know when to do, we're just going to solve for x. We do the same thing. We get x by itself. Divide by 0.5. We cancel that out. We get x equals 15 divided by 0.05 is 300. So 300 is the number of copies when they will charge the same amount. So x would equal 300. Now in order to solve for y, I can just plug x into any one of these and I will get my y. So I'm going to take y equals 0.07 times x, which is 300, and I plus 10. 0.07 times 300 is 21, plus 10 is going to give me my y equals 31. And that is the dollar amount that I would be paying. So y equals $31. So in an ordered pair, it would look like 331. So if I had a graph at when x is 300 and y is 31, that's where these two lines would intersect. Okay? Suppose my company was making 200 copies a week. Which company should I choose to do business with and why? So all I'm going to do is I'm going to say, okay, 200 copies, x is my number of copies. So when I plug 200 in to each of these equations, which company is going to charge more? Well, let's see. So I've got option 1, where this company charges 0.07 cents for copies, and I need to make 200 a week plus a $10 fee. So when I work that out, I get $24. 0.07 times 200 is 14, plus 10 is $14. Or I'm sorry, $24. So y equals 24. You can do that math on your calculator if you want. Option number 2, y is where they charge 2 cents per copy, and if I were to make 200 copies, but they charge a fixed fee of $25. Okay, so 0.02 times 200 is 4 plus 25, so y is going to equal $29. So in this situation, option 1 would be the better option choice for 200 copies. Okay. Last two problems. This is hard to see because it's so small. So we've got one wall inside the shoe store it uses to display walking shoes and running shoes. So I've got walking shoes and running shoes. So I'm going to say walking shoes is my X, running shoes is my Y. There are 135 pairs of shoes in this display. So right there we know that when we add the number of walking shoes plus the number of running shoes, it's going to be 135 pairs of shoes. That's what they're telling us. We also know that there are 1.5 times as many pairs of walking shoes as there are running shoes on the display. Well, okay, so if we know that walking shoes are X and running shoes are Y, 1.5 times as many pairs of walking shoes as there are running shoes. So they're saying walking shoes is going to be 1.5 times the amount of running shoes. So here we can take, we don't even need, this is our second equation. This is our first equation. This is our second equation. Now, let me just say this. We have been doing this all semester long where we have been taking whatever X is and plugging it into this equation. The only difference is that now X has a Y in it. But we've also been trying to say if we can get the same variables on the side, then we're going to be good. We can plug this whole value of X in here, and what would that do? That would give us Y plus Y. We know that we can add a number with a variable of Y plus another number with a variable of Y. We can add these two together. All we've done is taken this X equals and put it in there. Just the same as if it were 2 plus X equals 3. We could take, we solve that, subtract 2, X equals 1. We can take that 2 plus, and I can substitute this 1 in equals 3. I can substitute that in. We're doing the exact same thing over here. So when I get this equation, that's easy to solve. 1.5y plus another 1.5y. We know that a 1 is in front of that, so that's going to give me 2.5y equals 135. Then I'm going to divide both sides by 2.5. And I get, 135 divided by 2.5 equals y equals 54. Y is the number of running shoes. It's asking for walking shoes. So I know I have 54 pairs of running shoes. So I need to now, now instead of substituting my this in for X, now I'm going to substitute this in for Y. So I have X plus Y equals 135. X plus, now I'm going to take my Y value and substitute that in there. 135. And I get, subtract 54 from both sides. Can't write. X equals 81. So the number of walking shoes is 81. When I add 81 plus 54, that works out to be 135, so I know I got the answer correct. And I also know that if I multiply 54 times 1.5, that should give me 81. And when I put it in my calculator, 54 times 1.5 equals 81. So I've checked my work. I know I've gotten it correct. Number 2, you don't have to worry about. Number 3, a college student needs 11 classes that are worth a total of 40 credits. in order to complete her degree. The college offers 4 credit classes and 3 credit classes. Which system of equations can be used to determine the number of 4 credit classes? So F is 4 credit classes, and the student can take to complete her degree, where H is the number of 3 credit classes. So we know that she needs 11 total classes. So the 4 credit classes plus the 3 credit classes have to equal 11. And we also know that the number of 4 credit classes, F, 4 times F, the 4 credit classes plus the number of 3 credit classes has to equal 40 credit for her to continue on. So again, we can use the system of elimination. In order to do that, we can multiply this top equation by one of these numbers to get the same coefficient with a different sign. So let's just go ahead and multiply it by -4. Although it's asking for, well, both. We'll just figure out both. So when I do that, I'm going to get -4F minus 4H, and that's going to equal -44. So when I add these two together, I get 0. When I add these two together, I get -1H. When I add these two together, I get -4. So I'm going to divide both sides by -1 to get rid of my negative, and I get H equals 4. So she needs to take, whoever this is, needs to take 4. So H is going to equal 4. She needs to take 4 3 credit classes. So if I plug that back in up here, F plus H equals 11. F plus 4 3 credit classes must equal 11. Subtract 4 from both sides, and I'm going to get F equals 7. So she needs to take 7 4 credit classes. Okay. That's the end of the review. Thanks. Bye.